Okay, so we're going to learn how to do the length of a line segment, and we're just going to start with the first example. So to make round parts, programmable machine tools often use a coordinate system with the origin at the center of the part. They want to know how far apart are the centers of the mounting holes A and B in this cam. The coordinates are in centimeters, so that's really important to know when you're dealing with any type of tool. You need to know your units. So round your answer to the nearest tenth, which is 1 decimal place. So there's just a formula for length. All you need to know is that the length is equal. By the way, when I say length, it's the same thing as saying the distance. Okay, so if it asks for a distance, it's the length of something. So I use the lowercase letter d for distance, and we're trying to find the distance from A to B. So the distance from A to B, we need to make sure that we write that down. So the distance formula for anything is the square root of x2 minus x1 squared. Then you add y2 minus y1 squared. Okay, that's the formula for distance. This is probably what you want to write on your block note, and if you'd like an example and you have room, then you could copy this down on your block note, or just grab a sheet of regular paper. So we need to identify what the coordinates A and B are. Coordinate A, if you start with x first, it's -1, -2, it's -3 for x, and 1, 2, 3, 4, +5 for y. Remember that x is first and y is always second. Now for coordinate B, x is equal to 2 and y is equal to -4. So again, just be careful when you're writing your coordinates. You really don't want to mix those up. So I'm going to go ahead and rewrite those right over here so that I can see it when I do my work. And then we can just really start subbing in. What this formula is saying is that it wants you to subtract your x's. So let's go ahead and start by subtracting the x's. I'm going to start with the -3. If I start with the -3, I'm going to write -3 minus 2. So I'm going to put the big giant root. Don't forget to have the root go over all of these numbers. Always this bracket. -3 is my first x, and subtract 2. Close the bracket and square that. If we continue with this formula, it says to add the differences in the y's. Now be careful. If you started with the x being -3, you have to start with y equals 5. That's why I put a dot here. It kind of indicates the starting point, and then it goes towards the last point. So in the second instance, we're going to have 5 minus, be careful, it's not 5 minus 4 in this situation. It's actually 5 minus -4. I'm going to take that squared so I put it on the outside, which means I need to extend my root. So notice what I just did here. I put -4 in a bracket. The reason I did that is because when you subtract a negative, it becomes a positive. So we're going to rewrite and do a little bit of work here. -3 minus 2. That actually means when you have 3 negatives and 2 more negatives. So that's actually equal to -5. We're going to keep the bracket. The bracket is extremely important. If the bracket's not there, it's not -5 times -5. If the bracket isn't there, it's -5 times 5, which makes it a negative answer. And I know that's really confusing, so when I get back, we'll go over that. But for now, just make sure you keep the bracket and pay attention to that. Over here, we're going to rewrite, before doing any work, 5 plus 4. Okay. If I type this in, exactly this into my calculator, you should be typing a bracket, then a negative, then the 5, and then close the bracket. Make sure that you put that to the power of 2. Okay. Your calculator may have different steps, especially if it's backwards, but make sure you get a positive 25 as an answer. We're going to move on. 5 plus 4 is 9. Make sure to keep it in the bracket even though it's positive. If you get in the habit of keeping it in the bracket, then you won't run into too many problems. 9 squared means 9 times 9. 9 times 9 is 81. And if we add up these two things, we will get square root of 106. And a distance needs to actually have a meaningful unit. So you don't want to keep it as root of 106. You actually want to say that the distance is approximately 10.3 because we want to round it to the nearest tenth, as it said at the top. Nearest tenth is 1 decimal. So therefore, the centers of the mounting holes are about 10.3 centimeters apart. The centers of the mounting holes. Don't write that they are. They are approximately 10.3 centimeters apart. Okay. The word approximately, or you can use the word about, is extremely important in this case because you did round. It's not exactly 10.3. We're going to do another example for a distance. This is example 2. Again, you don't have enough room to put this on your block note, but the most important thing is that you just know the formula and how to apply the formula. So you may want to copy this down again on a sheet of lined paper. Entirely up to you if you just want to pay attention to the video and then watch it later. Okay, so an air ambulance uses a service grid to help estimate flying times and fuel requirements. Coordinates on this grid are distances in kilometers east and north of a reference point on the lower left corner of a map of Northern Ontario. A helicopter ambulance picks up a patient at point P. The nearest hospitals that they can provide the treatment of the patient needs are in Timmins at point T and in Sudbury at point S. So they want to know to which hospital should the helicopter take the patient. First thing you want to do is graph this. So I put a piece of graph paper, not piece of graph paper, but a coordinate chart on here. The scaling might be a little difficult, but let's see what we can do here. So my x's, I'm just going to analyze this before I actually do it. My x's, the lowest is 96, and it goes to the highest, which is 232. My y's go from 80 right up to 296. So I'm wondering if I can scale this maybe by 50s. That would be my best bet. I'm just going to check to make sure it works. So 25, 50, 100, 200. Yeah, I'm actually going to scale this by 25s. Okay. So if I do it by 25s, I'm going to have this type of scaling right here. Uh-oh. And that's not going to work because I need to go up to 296. Well, I'm just going to leave it like that for now. It's only going to be one little coordinate, so we'll make it work. Actually, x's go up to 232. So if I do the same thing over here, I'll be okay for my x's, but I won't be okay for my y's, which is not that much of a big deal if it's just one coordinate. So let's plot these points. 96 and 197. So point P is at 96, which is about here, and 197, which is about here. Okay. I mean, we're totally estimating this. Just put it as close as you think it is. Point T, which would be Timmins, starts at 200 for X, so down here, and goes up to 296. So that's the one. 296 is approximately right up here. So again, not the end of the world that we don't have it on the coordinate grid. It's just to kind of see what's happening. And Sudbury is 232, so 225 is right in the middle. 232 is shortly after that, and 80. I think 80 would be right about there. Okay. So it's really hard to tell visually which one would be the best hospital to bring you to. So what we need to do is if the patient is over here, we need to find which distance would be best. So is it best to bring him from where he is to Timmins, or would it be best to bring him from where he is to Sudbury? That's what we need to calculate. So we need to do 2 different distance formulas. Again, if you know how to use the formula, it's not too bad. Just know that distance is the concept that you need to apply here. So we need to do the distance from P to T. Okay. And we need to do the distance from the patient to Sudbury. So we're just going to copy down the formula once again. Square root of bracket x2 minus x1. All of that is squared. Don't forget to add y2 minus y1, and we're going to square that. I might as well write down the formula down here as well. And you may ask me, well, do I need to rewrite it? I already wrote it at the top. The answer is yes, you always have to rewrite it. So point P and T, make sure you use the right coordinate. We're going to subtract our x's. So I'm going to start by subtracting 200 minus 96 squared. I always also like to rewrite my coordinates right underneath. It takes 2 seconds to do it, and this way you won't make any mistakes. And I'll tell you why I do that. Because if I started with point T and subtracted 96, I need to start with 296 and subtract 197. So this gives me the order of which I'm doing things. Okay, so now I just do the subtractions. I do BEDMAS, and that means I need to subtract what's inside the bracket. Inside the bracket, it will give me 104. I know it's positive, but I'm going to leave it as in the bracket. And then we'll do 296 minus 197, which is 99, and we're going to square that. Okay, these are going to be pretty big numbers. So 104 squared is 10,816. 99 squared is 9,801. So then all we need to do is add up underneath the root. So 9,801 plus 10,816, which gives me 20,617. And we want an actual distance. So if we do the square root of all that, it's 143.6 approximately. Okay, it doesn't tell you how to round for this question, so usually 1 decimal is acceptable. So we'll go ahead and do the same work for distance P to S. Okay, so again, I'm going to go ahead and rewrite the coordinates, and this time I'm going to subtract starting from 96. So I'm going to go 96 minus 232. I'm going to square that. If I start with 96, I need to start with 197 for my y's. Okay, I made that fit. So if we do that, 96 minus 232 is negative 136. 197 minus 80 is 117. Notice how I kept both in the brackets again. So negative 136 squared means that it's negative 136 times negative 136. And we know that when we multiply two negatives, it should give us a positive. Okay. So just getting the answers here to 117 squared. I'm going to add up both those two answers, which is going to give me, again, a pretty high number. So be careful that you don't do a typo. It's 32,185. And the square root of that is approximately 179.4. Remember that these units are in kilometers. Okay. So if we know that the distance from the patient to Timmins is 143, and the patient from where he is to Sudbury is 179, you should know that the patient should go to Timmins because it's a shorter distance. So just make sure you justify. So we're going to say that the patient should be transported to Timmins because it is a shorter distance. Okay, so this is a complete answer of what I'm looking for. I want the formulas written down. I want the work all properly shown. And if you do all this, then you shouldn't run into any issues. So the supply is going to provide the work that you can practice with. Remember that these videos are posted on OneNote for you guys to make reference to.